vapor pressure. So, and also we have discussed some problems on RLB, that is relative loading of vapor pressure. That's important formula, that is P naught minus P divided by P naught is equal to X2. So that is relative loading of vapor pressure. So is equal to mole fraction of solute. To refer for solute, that is equal to N2 divided by N1 plus N2. That is number of moles of solute divided by total number of moles of solution. So that based on that already we discussed about some problems. So workout problems into so that I'm so in the same way, so we have discussed about I'm going to discuss another important qualitative property, that is osmotic pressure. Osmotic pressure. So that is indicated by pi. So before this qualitative property, that is osmotic pressure, so let me discuss some important concepts. So that is osmosis. And one more we have to discuss, that is semi-permeable membrane. Semi-permeable membrane. So what is the meaning of osmosis, or what is the meaning of semi-permeable membrane? So let's take a simple example. So now I am going to take a container. So in this container, so they are making two compartments. So making two compartments. This is one compartment and this is the other compartment. And these two compartments are separated by important membrane. That membrane is called as semi-permeable membrane. I will tell you what is the meaning of semi-permeable membrane. So in the one compartment, I am going to take a pure solvent. That is, I am going to take a solvent. So in another compartment, I am going to take a solution. So solvent is some amount of solute. So in one compartment, I am going to take a solution, and another compartment, I am going to take a solvent. So otherwise, so one more picture. So there is again making two compartments. Make two compartments. The two compartments are separated by again semi-permeable membrane. So here in one side, I am going to take a solution of lower concentration. I am going to take a solution of lower concentration. In another compartment, I am going to take a solution of higher concentration. So one is lower concentration, one is higher concentration. One is direct solution and one is concentrated solution. So in this case, semi-permeable membrane is the one which can allow only solvent molecules to pass through it. A membrane only solvent molecules pass allow, but not allows the solute particles to pass through it. So here semi-permeable membrane solvent and solution separate. So after some time we observe solution, for example, before the process. So here I solution level is after some time solution level is rise. So the solution rise some solvent molecules from solvent side, they are moving towards the solution side through the semi-permeable membrane. So that is the movement of the solvent molecules from solvent side to solution side through semi-permeable membrane. That process is called as osmosis. It is very important. What is meant by osmosis? The osmosis is nothing but the process of movement of solvent molecule from solvent to solution side through semi-permeable membrane. SPM, short form use nobody. Semi-permeable membrane. That process is called as osmosis. I will repeat once again. The process of movement of the solvent molecules from solvent to solution through semi-permeable membrane is called as osmosis. So, define one. So, how to define one? Right? Lower concentration, higher concentration. So, soft solvent molecules solute, but solute is very less because the concentration is less. So, here the solution of higher concentration, that is solvent is there and also some amount of solute is there. Higher compared to rest, each solution is compared to the solute is just same. That's why it is taken as a concentrated solution. So, here always the solvent molecules move from solution of lower concentration to solution of higher concentration. Remember, only there is a movement of the solvent molecules because semi-permeable membrane which allows only solvent molecules to pass through it but not solute particles. So that what is the meaning of osmosis and define the movement of the solvent molecules from solution of lower concentration to solution of higher concentration. ಅಥವಾ so movement of the solvent molecule from solvent to solution side through semi-permeable membrane ಅಥವಾ ಇನ್ನೊಂದು ಡಿಫೈನ್ ಮಾಡಿದ್ರೆ movement of the solvent molecules from solution of lower concentration to solution of higher concentration through semi-permeable membrane. So that is called as osmosis. So that's about the concept of osmosis. And then what is meant by semi-permeable membrane? Semi-permeable membrane is a membrane which allows only solvent molecules to pass through it as per but not solute particles. Solvent molecules matra allow pass but not solute particles. Those type of the membranes are called as semi-permeable membrane. That may be asked for 1 mark. What is meant by semi-permeable membrane and what is meant by osmosis? I will repeat once again. Osmosis is the process of movement of solvent molecules from solvent to solution through semi-permeable membrane, or so process of movement of the solvent molecules from the solution of lower concentration to solution of higher concentration through semi-permeable membrane. That is called as osmosis. The membrane which allows only solvent molecules to pass through it but not solute particles. Those type of the membranes are called as semi-permeable membrane. So semi-permeable membrane ki ಎರಡು type ಇದೆ. So one is natural semi-permeable membrane. So ಅದರಲ್ಲಿ ಬೇಕಾದ್ರೆ ಏನಂತ ತರಬಹುದು, plant membrane is one example. So there will be animal membrane is another example. This is an example of natural semi-permeable membrane. So animal membrane ತಗೊಂಡಾಗ pig's bladder is the best. It is acts as semi-permeable membrane. And one more is a synthetic semi-permeable membrane. The best example for synthetic semi-permeable membrane. It is synthesized so it will prepare as synthesized in the industries. So that is the best example is cellophane. Cellophane is the best example for a synthetic semi-permeable membrane. Totally, whatever it may be natural semi-permeable membrane or it may be synthetic, that can allow only solvent molecules to pass through it but not solute particles. So osmosis agಬೇಕಾದ್ರೆ semi-permeable membrane play very important role. Okay, so let me take some illustration about osmosis. So osmosis ಗೆ ಒಂದು illustration ತಗೊಂತಾ ಇದ್ದೀನಿ. So I'm going to consider a funnel. So I'm going to consider in the inverted position. So just I'm going to take a funnel. This is the funnel. The mouth of the funnel is covered or coated with a semi-permeable membrane. This is the funnel. So in this funnel, so mouth of the funnel is covered with the semi-permeable membrane. So in this funnel, just I am going to take a sugar solution, a strong sugar solution. So this is the level of sugar solution. So that is taken as a sugar solution or maybe salt solution. Totally the solution. So let's take a simple funnel. So the mouth of the funnel is covered with a semi-permeable membrane. It may be natural or synthetic. So in that funnel, I am going to take a sugar solution. The level of the sugar solution is up to here. So now this is present in inverted position. This inverted funnel is placed in a beaker that is consist of water. So this is the water that is present in a beaker. This funnel is placed in a beaker in an inverted position. So just in an inverted position. So this is the sugar solution inside the funnel. This is the semi-permeable membrane. This is the level of. So this is the funnel. So this is the level of the sugar solution. So that is placed in an inverted position in the water. So therefore, after some times, you can observe that the level of the sugar solution in the funnel rises up. So level of the sugar solution rises. Is to level it rise again. So as level rise again, what is the reason for that? So before placing the funnel into the water, so the level of the sugar solution up to here. ಸ್ವಲ್ಪ ಇರುತ್ತೆ. So when it is placed in a beaker, in a water that is present in a beaker, the level of the sugar solution inside the funnel is rises up. ಯಾಕೆ? What is the reason for this ಅಂದ್ರೆ? So here there is a water and sugar solution is a solution. So solvent molecules go from solvent to solution, that is called as osmosis. So ಇಲ್ಲಿ ನಿಮಗೆ ಏನಾಗಿದೆ, ವಾಟರ್ ಇದೆ, ಸೊ ಸೆಮಿ ಪರ್ಮನೆಂಟ್ ಮೆಂಬ್ರೇನ್ ಇದೆ, ಸೆಮಿ ಪರ್ಮನೆಂಟ್ ಮೆಂಬ್ರೇನ್ ಒಳಗಡೆ ಇಲ್ಲಿ ಏನಿದೆ ಫನಲ್ ಅಲ್ಲಿ ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ಇದೆ. ಸೊ ದ ವಾಟರ್ ಈಸ್ ಮೂವಿಂಗ್ ಇನ್ಸೈಡ್ ದ ಫನಲ್ ಥ್ರೂ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್. So when the water moving or solvent moving from water to funnel or to the sugar solution through semi-permeable membrane, the process is nothing but osmosis. Andre why the level of the sugar solution is rises in the funnel is mainly because of osmosis. That is a simple illustration about the osmosis. Let me take a simple funnel in the inverted position. So that is consists of or covered with, the mouth is covered with a semi-permeable membrane, and this is consists of a strong sugar solution. Now this funnel, which is consists of a strong sugar solution, is placed in inverted position and immersed in water that is present in a beaker. And after some time, you can observe that the level of the sugar solution rises up, mainly due to the osmosis. Nothing but these water molecules, the water molecules and the water molecules are moved inside the funnel through the semi-permeable membrane. So the water is a solvent. There is no solute here. So, but inside the funnel there is a sugar solution. There is a solution. So, definitely there is of solute. That is sugar is a solute here. So, therefore concentration is ಜಾಸ್ತಿ ಇರುತ್ತೆ. Solvent ಮಾತ್ರ ಇದೆ, ಇಲ್ಲಿ concentration ಇಲ್ಲ. So, again lower concentration to higher concentration ಅಥವಾ solvent to solution through semi-permeable membrane. That process is nothing but osmosis. Totally, the level of the sugar solution in funnel is rises only because of osmosis. That's a simple illustration about the osmosis. And some natural processes are the best examples. ಕೆಲವೊಂದು ನ್ಯಾಚುರಲ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ ಆಸ್ಮೋಸಿಸ್ ನಿಮ್ಗೆ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಅದು ಯಾವ್ಯಾವ ಅಂತ ನೋಡಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸೊ ಹೋಮ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಮನೆಗಳಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಪಿಕಲ್ಸ್ ಮಾಡ್ತಾರೆ, ನಥಿಂಗ್ ಬಟ್ ಉಪ್ಪಿನಕಾಯಿ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಸೊ ದ ರಾ ಮ್ಯಾಂಗೋನ ಚೆನ್ನಾಗಿ ಕಟ್ ಮಾಡಿ, ಸೊ ದಟ್ ಈಸ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ದ ಶುಗರ್ ಸೊಲ್ಯೂಷನ್. ಅದಕ್ಕೆ ಶುಗರ್ ಹಾಕ್ತಾರೆ, ಸ್ವಲ್ಪ ಖಾರ ಎಲ್ಲ ಹಾಕಿ ನಿಮ್ಗೆ ಅದು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ಹಾಕಿ ಸ್ವಲ್ಪ ದಿನ ಅದನ್ನ ಹಂಗೆ ಬಿಡ್ತಾರೆ. ಸೊ ನೀವು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ಅದನ್ನ ಪಿಕಲ್ಸ್ ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಅದರ ರಾ ಮ್ಯಾಂಗೋಸ್ ಸೈಜ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಅಂಡ್ ಆಫ್ಟರ್ ಪಿಕಲ್ ಫಾರ್ಮೇಶನ್ ಆದ ಮೇಲೆ ಅದ್ರ ಸೈಜ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ದ ಸೈಜ್ ವಿಲ್ ಬಿ ಡಿಕ್ರೀಸಸ್. ನಥಿಂಗ್ ಬಟ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ಟ್ರಿಂಕ್ ಆಗಿರುತ್ತೆ. ಸೊ ಈಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ರಾ ಮ್ಯಾಂಗೋ ಕಟ್ ಮಾಡಿ ಹಾಕಿದ್ದೀರಾ ಅಂತಂದ್ರೆ ಅದೇನಾಗುತ್ತೆ, ಸ್ಟ್ರಿಂಕ್ ಆಗಿರುತ್ತೆ. So why it is? Because of osmosis. Nothing but the raw mangoes loses the water. So due to osmosis, when they are placed in the saline solution, nothing but in the salt solution. So therefore they are strings to pickle. And string again pickle again formation agate. That is one of the best example. And another example, wilted water. So wilted flower revive when it is placed in the fresh water. Wilted flower ಅಂತಂದ್ರೆ ಈಗ ಬಾಡೋಗಿದೆ ಅಂತ ಹೇಳಿ, ಸ್ವಲ್ಪ ದಿನ ಹಂಗೆ ಬಿಟ್ಟರೆ ಹೂ ಬಾಡೋಗಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಮತ್ತೆ ಅದಕ್ಕೆ ಏನಾದ್ರು ಫ್ರೆಶ್ ವಾಟರ್ ಹಾಕಿದಾಗ ಅಗೇನ್ ಅದು ಫ್ರೆಶ್ ಫ್ಲವರ್ ಆಗಿ ಇದಾಗುತ್ತೆ. ಸೊ ಅದು ಟರ್ನ್ ಆಗ್ತಾ ಇದೆ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಬಿಕಾಸ್ ಆಫ್ ಆಸ್ಮೋಸಿಸ್. ಅಂಡ್ ಅಗೇನ್ ರೈಸಿಂಗ್ ಆಫ್ ವಾಟರ್ ಇನ್ ರೂಟ್ಸ್ ಅಂಡ್ ಸ್ಟೆಮ್. ರೂಟ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ಸ್ಟೆಮ್ ಅಲ್ಲಿ ವಾಟರ್ ರೈಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಫ್ರಮ್ ಅರ್ತ್. ಸೊ ಅರ್ತಿಂದ ಏನಾಗುತ್ತೆ, ಆಮೇಲೆ ರೈಸ್ ಆಗುತ್ತೆ ಥ್ರೂ ಫ್ಲೋಯಮ್ ಅಂಡ್ xylem ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಬಿಕಾಸ್ ಆಫ್ ಆಸ್ಮೋಸಿಸ್. ಅಂಡ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಎಕ್ಸಾಂಪಲ್, preservation of meat for long time by adding sugar, salt, and by preservation of the fruits by adding sugar. So our preservation ಆಗಬೇಕಾದ್ರೆ ಅದು ಸಹ preservation ಆಗೋದು only because of osmosis. ಅದು ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ natural process. And another one is the people who are taking the large amount of the salt ಅಥವಾ salty foods. ಯಾವ ನಿಮಗೆ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸಾಲ್ಟ್ ಅನ್ನ ಅಥವಾ ಸಾಲ್ಟಿ ಫುಡ್ ಅನ್ನು ಯಾರು ಜಾಸ್ತಿ ತಿಂತಾರೋ, ಸೊ ದೇ ಆರ್ ವೆರಿ ಪಫಿನೆಸ್, ಅಂದ್ರೆ ಸ್ಮೆಲ್ ಇರ್ತಾರೆ, ದಪ್ಪ ಇರ್ತಾರೆ ತುಂಬಾ. ಸೊ ಯಾಕೆ ಅಂದ್ರೆ what happens here is the water is retained, ಅಥವಾ retention of water in tissues and intracellular spaces. That is also due to osmosis. That causes swelling or puffiness. That condition is called as edema. That is, people who are taking large amount of salt or salty foods experiences the retention of water in tissues and intracellular spaces due to osmosis, and they causes the condition, so that is called as edema, nothing but puffiness ಅಥವಾ swelling ಅಥವಾ ದಪ್ಪ ಜಾಸ್ತಿ ಇರ್ತಾರೆ. So that is also because of osmosis. These are all some examples, natural process ಅಲ್ಲಿ examples ಇವೆಲ್ಲ. So ಎಲ್ಲಾದ್ರೂ ನಮಗೆ ಗೊತ್ತಿಲ್ಲದೆ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, osmosis process ಆಗ್ತಾ ಇರುತ್ತೆ. So these are some examples of the osmosis which are takes place in the natural process. Okay, so that's about the osmosis and semi-permeable membrane, and what are the examples for the semi-permeable membrane and some simple illustration for osmosis. Now we are going to enter the very important qualitative property, that is called as osmotic pressure. So one more natural example is there. So natural process is there. So I think carrot become limp after long time. You carrot in a long time after a victory in the right. So that loses the water, that will become limp and bend again. So the stiffness is bend again. So matte adana ನೀವು water ಹಾಕಿ. So when it is placed in water, again it regains its shape and also size. ಅದೇ size ಗೆ ಮತ್ತೆ original size ಇರುತ್ತೆ, ಅದೇ size regain ಆಗುತ್ತೆ. Again because of osmosis. So that is the carrot become limp due to loss of water, and again it's regain its shape or size when it is placed in the water. That is also because of osmosis. Number of examples are there. So natural agi namage osmosis ಆಗ್ತಿರೋದು ತುಂಬಾ examples ಇದೆ. Some examples are explained. So now we are going to discuss, that is osmotic pressure, a very important concept for your competitive exams. That is the second qualitative property. So already we discussed about the RLP, that is direct lowering of vapor pressure, and again one more, osmotic pressure. So what is the meaning of osmotic pressure? So what is the formula to calculate the osmotic pressure? So what is the meaning of reverse osmosis? That are all the concepts coming under the osmotic pressure. So now, let me take a simple diagram. So in this diagram, just I am going to make two compartments. The compartments are separated by semi-permeable membrane. So in the one side, I am going to take a pure solvent in one compartment, and in the other compartment, I am going to take a solution. So or in one compartment solution of lower concentration and in another compartment let me take solution of higher concentration. So here I am going to explain by taking solvent and solution in the two compartments, and those compartments are separated by semi-permeable membrane. So that's about the level of the solution and solvent. So semi-permeable membrane that can allows only solvent molecules to pass through it. So when the two compartments containing solution and solvent separated by semi-permeable membrane, we know that the solvent molecules are moving towards the solution. That process is called as osmosis. So ಈ ಕಡೆ ಬರ್ತಾ ಏನು ಮಾಡ್ತಾರೆ, osmosis ಅಂತ ಹೇಳ್ತಾರೆ. So ನಾನೇನು ಮಾಡಬೇಕು ಅಂದ್ರೆ just I want to prevent the osmosis. ಅಂದ್ರೆ solvent molecules from solvent side to solution side, or the flow of solvent molecules from solution of lower concentration to higher concentration. ಆ ಒಂದು ಫ್ಲೋ ಆಗೋದನ್ನ solvent molecules ನ ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ ಪ್ರಿವೆಂಟ್ ಮಾಡಬೇಕು, ಅಂದ್ರೆ ಸ್ಟಾಪ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ our intention is to stop the process of osmosis. Osmosis ನ ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ ಆಗೋದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು, ಪ್ರಿವೆಂಟ್ ಮಾಡಬೇಕು, ಸ್ಟಾಪ್ ಮಾಡಬೇಕು. ಈಗ ಅಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಏನು ಅಂದ್ರೆ solvent molecules are moving from solvent side to solution side, or lower concentration to higher concentration. ಈ ಕಡೆ ಬರ್ತಕ್ಕಂಥ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ಬರ್ತಕ್ಕಂಥ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು, ಅದಕ್ಕೆ ಸ್ಟಾಪ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ we are going to apply the pressure on one side. ಯಾವ ಕಡೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ? ಇನ್ ಕೇಸ್ ನಾವು ಈ ಕಡೆ ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಇಲ್ಲಿಗೆ ಏನಾದ್ರು ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಸೊ ಆಸ್ಮೋಸಿಸ್ ಪ್ರೋಸೆಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಈ ಕಡೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಆಲ್ರೆಡಿ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಡೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಅಗೇನ್ ಈ ಪ್ರೆಷರ್ ಇದ್ರ ಮೇಲೆ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ದ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಮೂವಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದ ಸೊಲ್ಯೂಷನ್, ಅಂದ್ರೆ the process of osmosis will be increases. So therefore, to avoid this flow of solvent from solvent to solution side, ಈ ಕಡೆ ಬರ್ತಕ್ಕಂಥದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ we are going to apply the pressure on the solution side. Solution side ಗೆ ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಯಾವಾಗ ನೀವು ಸೊಲ್ಯೂಷನ್ ಸೈಡ್ ಗೆ ಪ್ರೆಷರ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತೀರೋ ಈ ಕಡೆಯಿಂದ ಬರ್ತಕ್ಕಂಥ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ ಕಡೆಯಿಂದ ಬರುತ್ತೆ, ಅವಾಯ್ಡ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿಗೆ ಆ ಕಡೆ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗೋದಿಲ್ಲ, ಮೂವ್ ಆಗೋದಿಲ್ಲ. So therefore, whatever the pressure that is going to apply on the solution side just to stop osmosis, ನೀವು ಯಾವ ಅಪ್ಲೈ ಮಾಡಬೇಕಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಸೈಡ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಅಥವಾ ಅಲ್ಲಿ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೊಲ್ಯೂಷನ್ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ತಗೊಂಡಿದ್ರೆ we are going to apply the pressure on the higher concentrated solution side so that we can prevent the osmosis. So whatever the pressure that we are going to apply on the solution side just to stop the flow of solvent molecule from solvent to solution side. ಈ ಕಡೆ ಬರ್ತಿರ್ತಕ್ಕಂಥ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು, ಪ್ರಿವೆಂಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ we are going to apply the pressure on the solution side. So therefore the pressure which is applied on the solution side to just stop that pressure is called as osmotic pressure. That is the concept behind the osmotic pressure. One mark ಹೇಳ್ತಾನೆ define osmotic pressure ಅಂತ ಹೇಳ್ತಾನೆ. That is the pressure applied on solution of higher concentration just to stop osmosis. Simple. The pressure which is applied on solution of higher concentration side just to stop osmosis, that is called as osmotic pressure ಅಂತ ಹೇಳ್ತೀವಿ. ಅಥವಾ osmotic is also defined as the pressure which is applied on the solution side just to prevent osmosis. Again ನಾವು lower concentration solution higher concentration solution ತಗೊಂಡಾಗ ನೀವು ಈ ತರ ಹೇಳಬೇಕಾಗುತ್ತೆ, pressure applied on the solution of higher concentration side just to stop osmosis. ಅಥವಾ ಬರೀ solvent ಈ ಕಡೆ solution ತಗೊಂತಿದೀವಿ ಅಂದ್ರೆ so the process of the pressure which is applied on the solution side just to stop osmosis, the concept that the pressure is called as osmotic pressure and indicated by pi. So I will have to explain once again. So next I am going to take a container that make two compartment by using semi-permeable membrane. Now one side I am going to take a solvent and one side solution. Athwa solution of lower concentration and solution of higher concentration. So now ಆಗೆ ಬೇಕಿದ್ರೆ ಏನು ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ solvent molecules are move from lower concentration to higher concentration or solvent to solution side. So that process is called as osmosis. Now our intention is to stop the osmosis. Osmosis stop ಮಾಡಬೇಕು. So that I am going to apply the pressure on the solution side just to stop the osmosis. That pressure is which is applied on the solution side is called as osmotic pressure indicated by pi. So that is a one mark question. Define osmotic pressure ಅಂತ ಕೇಳ್ತಾನೆ. So the pressure which is applied on the solution of higher concentration side just to stop osmosis, that is called as osmotic pressure. So now I am going to take for dilute solution. For dilute solutions, so osmotic pressure is directly proportional to concentration of the solution. Osmotic pressure is directly proportional to concentration of the solution. What is the concentration here? The concentration is the molarity. So here the concentration C is molarity. That is number of moles of solute dissolved in 1 liter of the solution, or 1 dm cube of solution. So for dilute solutions, the osmotic pressure directly proportional to concentration at a given temperature. At a given temperature T. So that T should be in Kelvin. So now this proportionality is going to add in the constant, the proportionality constant Y is equal to K into C, where K is equal to R into T. So K is equal to R into T. So what is R? So that is R is a gas constant. That value is very, very important. 0.0821 liter atmosphere per Kelvin per mole. That is R value, gas constant 0.0821 liter atmosphere per Kelvin per mole. This is very, very important for problems. Sometimes osmotic pressure atmosphere R value use ಮಾಡಬೇಕಾಗುತ್ತೆ. Sometimes calculate the osmotic pressure in bars ಅಂತ ಕೇಳ್ತಾರೆ. Bar is also unit of pressure. So our time only R value is taken as 0.083 liter per Kelvin per mole. Liter per Kelvin per mole. So ನೋಡ್ಕೋಬೇಕು ಯಾವ್ದು ಕೇಳಿದೆ ಅಂತ. In case R value ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಬಾರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ osmotic pressure ಯೂನಿಟ್ ಏನಾಗುತ್ತೆ ಬಾರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. In case R value ಏನಾದರೂ atmosphere ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ so Y value ಏನಾಗಿರುತ್ತೆ atmosphere ಅಲ್ಲಿ ಕೊಡಬೇಕಾಗುತ್ತೆ. So therefore equation ಏನಾಗುತ್ತೆ ನೋಡಿ, Y is equal to RTC. pi is equal to RTC or CRT ಅಂತ ಹೇಳ್ತೀವಿ ಸಿಂಪ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಳೋದಕ್ಕೆ. So pi is equal to CRT or RTC. What is R? Gas constant, the value in atmosphere and also bar ಎರಡರಲ್ಲೂ ಕೊಟ್ಟಿದ್ದೀನಿ. And T is the temperature in Kelvin. Very important. Problem ನೋಡಬೇಕಾದ್ರೆ ಒಂದು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ. So ಅದನ್ನ by adding 273.15 or 270 approximately, so Kelvin ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. C is the concentration in terms of molarity. So but we know that, so C concentration is nothing but molarity is equal to number of moles of solute divided by volume of solution in liters. I think it's clear. N2, N is the number of moles, 2 referred for solute, already told in the previous classes. V is the volume of solution in liters. So adu matte ಏನು ಮಾಡಬಹುದು, number of moles of solute, that is N2 is equal to, what's the formula for number of moles? Number of moles is equal to mass by molar mass. So mass is indicated by W, molar mass indicated by capital M. So this is applied for solute here. Number of moles of solute is equal to mass of solute divided by molar mass of the solute. So again volume in liters ಅಂತ ಇದೆ, ಅದನ್ನ ನಾವು ಏನು ಮಾಡಬಹುದು, ml ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡಾಗ that is divided by 1000 ಅಂತ ಮಾಡ್ಕೊಂತೀವಿ. So therefore finally ಏನಾಗುತ್ತೆ, so number of moles of solute is equal to WO2 divided by m2 into volume in liters ಅಂತ ಬರೀಬೇಕಾದ್ರೆ ಮತ್ತೆ volume in ml ತಗೊಂಡಾಗ 1 liter is equal to 1000 ml. So ಅಲ್ಲಿ volume in liters ನ ml ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾರೆ, 1000 ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಮತ್ತೆ ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡಾಗ ಮತ್ತೆ ಏನಾಗುತ್ತೆ, ನ್ಯೂಮರೇಟರ್ ಬರುತ್ತೆ. So that is 1000 divided by volume in ml. So that is the concentration, that is molarity. Now substitute the value of this concentration in this equation. So what happens? Call it as equation number 1. So equation 1 becomes what happens? Pi is equal to CRT. Simply RT is in the bracket, just taken as a CRT. C is the molarity. Substitute the value here. That is WO2 into RT into 1000 divided by M2 into V in ml. So that is the formula to calculate the osmotic pressure of the solution. It's a very important and direct question will ask in the competitive or as well as the theory examination for 3 marks. So calculate the osmotic pressure of the solution, which is consists of a solute, this amount, and solute the molar mass near find out ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. And they will give the volume of the solution and also the temperature. Sometimes temperature is given in the Kelvin, directly you can substitute. So sometimes they are given in the degree Celsius, just degree Celsius converted into Kelvin by adding 273. So this is the final formula to calculate the osmotic pressure of the given solution. That is terms correct agotili, pi is equal to W2 RT into 1000 divided by M2 into V in ml. So what is WO2? That is mass of solute, to refer for solute, and R is a gas constant value. So sometimes R value ಇದು ಕೊಟ್ಟಿರ್ತಾರೆ, ಅಥವಾ ಇದು ಕೊಟ್ಟಿರ್ತಾರೆ. ನೀವು ಇಲ್ಲಿ R value ಯಾವುದು ಕೊಟ್ಟಿದ್ದೀರೋ, ಸೊ ಯಾವ ಬೇಸಿಸ್ ಇದನ್ನ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ 100% pi value ಯಾವುದು ಬರಬೇಕು, ಯೂನಿಟ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಬರಬೇಕಾಗುತ್ತೆ. ಸೊ ಬಾರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ pi value ಬಾರ್ ಅಲ್ಲಿ ಕೊಡಬೇಕಾಗುತ್ತೆ. So temperature in Kelvin, T refer for temperature in Kelvin, M2 refer for molar mass of solute, and V refer for volume of solution in ml. Sometimes literal cell ಕೊಟ್ಟಿರ್ತಾನೆ, ಲೀಟರ್ ಇಂದ ಮತ್ತೆ ಏನು ಮಾಡ್ಕೊಳ್ಳಿ, so volume ml ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, but it is multiplied by 1000 ಮಾಡ್ಕೊಳ್ಳಿ. So this is a very important equation to calculate the osmotic pressure of the given solution. So now already we said the osmotic pressure is one of the colligative property. So what is the meaning of colligative property? Colligative property is a property which depends on number of solute particles relative to total number of solute particles, but not on the nature of the particles and the nature of solute particles. So again, so in this equation we come to know that pi is proportional to, so from this equation, that is pi is equal to, C is the concentration. So concentration in baribodu. So pi is equal to R into T into C concentration N2 divided by V in ml. So again, from this equation we come to know that pi is proportional to N2, where N2 is the number of moles of solute. So therefore, the osmotic pressure is a colligative property because it depends on the number of moles of solute. Nothing but number of solute particles, but not on the nature. So our nature ಏನು ಬೇಕಾದ್ರೂ ಆಗಿರಬಹುದು. Number of solute particles ಮೇಲೆ ಅಥವಾ number of solute particles ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರೋದ್ರಿಂದ osmotic pressure is taken as a colligative property. Why the osmotic pressure is colligative property? So because it depends on number of solute particles, but not on the nature of solute particles. That's why osmotic pressure is also one of the colligative property. And what are the importance of this qualitative property? Sorry, osmotic pressure measurement. Osmotic pressure measurement ಏನು ಮಾಡ್ತೀವಿ ಅದನ್ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿದೆ. So the best method to find the molar masses of macromolecules like biomolecules, proteins, lipids ಅಥವಾ polymers ಈ ತರ macromolecules molar mass ನ find out ಮಾಡಬೇಕಾದ್ರೆ among the four qualitative properties which one is the better one anta kelidane. That is the competitive exam question. So the better method is osmotic pressure method. So this is a very important method. Osmotic pressure method is very useful to determine the molar mass of solute in macromolecules. Macromolecules ಅಂದ್ರೆ for example biomolecules ಬರುತ್ತೆ. So biomolecules carbohydrates ಆಗಬಹುದು, lipids, proteins ಆಗಬಹುದು, ಅಥವಾ some polymers ಆಗಬಹುದು. Polymers are also macromolecules because they have the higher molecular mass. So molar mass ಜಾಸ್ತಿ ಇರುತ್ತೆ. So especially this osmotic pressure method is very useful to determine the molar mass of the solute in the biomolecules. Which are not stable at high temperature, and also it is a very good method. Osmotic pressure method is a very good method to determine the molar mass of solute in the polymers, which have poor solubility. So in the competitive exam, among the following method, which is the best method to determine the molar mass of the solute in macromolecules of the kelida. So the best method is osmotic pressure method. Option method, that is relative lowering of vapor pressure method, and one is osmotic pressure method, elevation of boiling point method, and also the depression of freezing point method. So in all the method put in the next. So the best method is osmotic pressure method, and osmotic pressure measurements is very useful to determine the molar mass of the macromolecules like biomolecules, proteins, lipids, and also the polymers, etc. And especially is very useful to determine the molar mass of the biomolecules which are not stable at a high temperature, and applicable for the very useful to determine the molar mass of polymers which have poor solubility. And ಇಲ್ಲಿ ನಿಮಗೆ ಈ ತರ ಕ್ವೆಶ್ಚನ್ ಗಿಂತ ಯಾಕೆ ಅದನ್ನ ಬೇರೆ ಮೆಥಡ್ಸ್ ಗಿಂತ ಯಾಕೆ osmotic pressure measurements ನಿಮಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ? Why this method is very useful to determine the molar mass of the macromolecules? That is very important. So reason for this is ಇದಕ್ಕೆ reason ಏನಂದ್ರೆ its magnitude ಅಂದ್ರೆ osmotic pressure value magnitude ಏನಾಗಿರುತ್ತೆ? Its magnitude is larger even for very dilute solutions. We know that colligative property, especially dilute solution ಗೆ ಅಪ್ಲೈ ಮಾಡ್ಕೊಂತೀವಿ. ನಾನು osmotic pressure ಇರಬೇಕಾದ್ರೂ for a dilute solution ಅಂತ ತಗೊಂಡಿದ್ದೆ. ಆರೋಲಿಪಿನ derivation ಮಾಡಬೇಕಾದ್ರೆ for dilute solution N2 is less than N1 ಅಂತ ತಗೊಂಡು ನಾನು derivation ಕೊಟ್ಟಿದ್ದೆ. ಸೊ ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಯಾಕೆ osmotic pressure ಮೆಥಡ್ ಅನ್ನೇ ನೀವು ಯೂಸ್ ಮಾಡ್ತಾರೆ macromolecules molecular mass molar mass ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕಿಂತ? ಬಿಕಾಸ್ ಸೊ even for the very dilute solution ಅಂದ್ರೆ ಸಲ್ಯೂಟ್ ಸ್ವಲ್ಪ ಇದ್ರೂ ಸಹ we can easily determine the molar mass by using the osmotic pressure method. ಅಂದ್ರೆ ಆ ಸೊಲ್ಯೂಷನ್ osmotic pressure ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ we can easily calculate the molar mass of this solute. Remember pi is equal to W2, so RT into 1000 by M2. So now the osmotic pressure method is very useful to determine the molar mass of solute. ಯಾಕೆಂದ್ರೆ even for the very dilute solution, ತುಂಬಾ ಡೈಲ್ಯೂಟ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಸಲ್ಯೂಟ್ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ, ಆದ್ರೂ ಸಹ ಅದನ್ನ ಏನ್ ಮಾಡ್ಕೋಬಹುದು, ಅದಕ್ಕೆ osmotic pressure ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂಡು by using the osmotic pressure value W2, RT and V we can easily calculate the molar mass. So therefore, even for the very dilute solution its magnitude is very large, hence it is very useful to determine the molar mass of the to find out the molar mass of the biomolecules which are not stable at high temperature, and also determine the molar mass of polymers which are poor solubility. Totally, it is very useful to determine the molar mass of the macromolecules. And ಏನಕ್ಕೆ ಅಂತ ರೀಸನ್ ಗೊತ್ತಿರಲಿ ಯಾವ ಮೆಥಡ್ ಅಂತಂದ್ರೆ ದಟ್ ಈಸ್ osmotic pressure method. ಯಾಕೆ ಅಂತಂದ್ರೆ because osmotic pressure value, that is a magnitude, its magnitude is very very high even for the dilute solution, so that you can easily determine the molar mass of the solvent. So that's about the osmotic pressure and some important property exam questions. And remember, this is a very very important equation for the osmotic pressure calculation. So ಹಿಂಗೆ ನೀವು RLP ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಮಾಡಿದ್ರು ಅದೇ ರೀತಿ ಈ ಕ್ವೆಶ್ಚನ್ ನ ಈ ಒಂದು osmotic pressure ಬೇಸ್ ಮೇಲೆ ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. This is the equation. So terms ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು. Pi is osmotic pressure, W is the mass of solute, M2 is the molar mass of solute, R is the gas constant, that is 0.0821 liter atmosphere per Kelvin per mole. So bar al express ಮಾಡಬೇಕಾದ್ರೆ that is 0.083 liter bar per Kelvin per mole. T is the temperature in Kelvin. Remember, degree Celsius ಕೊಟ್ಟಿದ್ರೆ Kelvin ಮಾಡ್ಕೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. V is the volume of solution and into 1000. So that's about the concept of osmotic pressure. So what is meant by osmotic pressure? Osmotic pressure is the pressure which is applied on the solution of higher concentration side to just stop the osmosis. Athwa the pressure which is applied on the solution side just to stop osmosis, that is called as osmotic pressure. So osmotic pressure is directly proportional to concentration. So and also pi is equal to CRT. So that is R and T are the R is the gas constant, that's a constant value, M is the temperature in Kelvin. And substitute the value of molarity. C is nothing but molarity here. W2 divided by M2 into 1000 divided by VNML. Substitute the value of C, you will get the osmotic pressure equation. Okay, so that's about the osmotic pressure. So otherwise, so one more concept that is called as reverse osmosis. One more concept on this osmotic pressure and osmosis, that is reverse osmosis. So the well known, that is simply written as RO. So where is in the RO? That is in water filter. In ಮನೆಗಳಲ್ಲಿ ವಾಟರ್ ಫಿಲ್ಟರ್ಸ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಅಲ್ಲಿ ಸಿಂಪಲ್ ಆಗಿ RO ಅಂತ ಹಾಕಿರ್ತಾರೆ. ಸೊ ನೀವು ಸುಮಾರು ವಾಟರ್ ಫಿಲ್ಟರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ. ಸೊ ಆ ವಾಟರ್ ಫಿಲ್ಟರ್ಸ್ ಅಲ್ಲಿ RO ಅಂತ ಬರ್ತಿರ್ತಾರೆ. So RO is nothing but reverse osmosis. It's a very 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 important basic principle that is used to purification of water or desalination of seawater. So let me explain to you what is the meaning of reverse osmosis and what is the condition for the reverse osmosis. ಈಗ ಸುಮ್ಮನೆ ನಿಮಗೆ reverse osmosis ಆಗೋದಿಲ್ಲ. There is a one condition. ಆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಮಾತ್ರ ನಿಮಗೆ reverse osmosis ಆಗುತ್ತೆ. osmosis is ಆಗುತ್ತೆ. ಈಗ ನಾವೇನು ಮಾಡಬೇಕು, osmosis ನ ರಿವರ್ಸ್ ಮಾಡಬೇಕು. And then we are going to change the reverse the direction of osmosis. So let me take a simple example. So now here I am going to take a container. So the container, make it as two compartments by using semi-permeable membrane. So this is a semi-permeable membrane. So here I am going to take a solvent in one compartment, right side compartmentally, and in the left side compartment I am going to take a solution. So this is the level of solution and this is the level of solvent. So after some time what happens, the solution level will rise up because the solvent molecules are moving from solvent side to solution side through semi-permeable membrane. That process already discussed, that is called as osmosis. So to just stop the osmosis, we are going to apply the pressure on each side, that is on solution side. So just I am going to apply the pressure. That pressure applied on the solution side just to stop osmosis. That is called as osmotic pressure. That is pi. So ಎಲ್ಲ terms ಬರ್ತವೆ. So solvent ತಗೊಂಡಿದ್ದೀನಿ, solution ತಗೊಂಡಿದ್ದೀನಿ, separated by semi-permeable membrane. So ಅದೇ ಬಿಟ್ಟಿದ್ದೀರಾ ಅಂತಂದ್ರೆ the level of the solution is increases because the solvent molecules are moved from solvent side to solution side through the semi-permeable membrane. That process is called as reverse osmosis. So again, the process of movement of the solvent molecule from solvent side to solution side just prevented or stopped by applying the pressure on the solution side. That pressure is called as osmotic pressure. Already have discussed that. So ಈಗ ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ our intention is to reverse the osmosis process. ಈಗ osmosis ಅಂದಾಗ ಏನಾಗ್ತಾ ಇದೆ, so let me take simple example. So there is osmosis ಅಂದಾಗ So ಈ ಕಡೆ ಬರುತ್ತೆ. So blue ಅಲ್ಲಿ ಏನು ಬರ್ತಿದ್ದೀನಿ, so blue pen ಅಲ್ಲಿ ಏನು ಬರ್ತೀನಿ, that is osmosis. So ಇದು ಸ್ಟಾಪ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ I am going to apply the pressure, that is osmotic pressure. So ಈಗ ನಮ್ಮ ಇಂಟೆನ್ಷನ್ ಏನಪ್ಪ ಅಂದ್ರೆ ಆಸ್ಮೋಸಿಸ್ ನ ರಿವರ್ಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ the solvent molecules are moved from solution side to solvent side. So ಅಥವಾ lower concentration to higher concentration, that is osmosis. ಈಗ ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಂದ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೆ ಸಾಲ್ವೆಂಟ್ ಮೂವ್ ಆಗಬೇಕು. ಸರ್ ಇದು ಸಾಲ್ವೆಂಟ್ ಇದೆಯಾ? ಎಸ್ ಆಫ್ ಕೋರ್ಸ್ ದಿಸ್ ಇಸ್ ಅ ಸೊಲ್ಯೂಷನ್, ಇಟ್ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ ಸಾಲ್ವೆಂಟ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಸೊಲ್ಯೂಟ್. ಈಗ ಏನಾಗಬೇಕು ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಇರತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಕಡೆ ಮೂವ್ ಆಗಬೇಕು, ಈ ಕಡೆ ಕಂಪಾರ್ಟ್ಮೆಂಟ್ ಮೂವ್ ಆಗಬೇಕು. ಸೊ ಅಂದ್ರೆ ನಾವು ಈ ತರ ಮೂವ್ಮೆಂಟ್ ಕೊಡಬೇಕು. ಸೊ ಈ ತರ ಈಸಿ ಆಗುತ್ತೆ, ದಟ್ ಈಸ್ ಆಸ್ಮೋಸಿಸ್. ಅದು ಸ್ಟಾಪ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಜಸ್ಟ್ ಬೈ ಅಪ್ಲೈಯಿಂಗ್ ದ ಪ್ರೆಷರ್, ದಟ್ ಈಸ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್. ಈಗ ನಾನು ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಇಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಇರತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ಏನ್ ಮಾಡಬೇಕು, ಸಾಲ್ವೆಂಟ್ ಕಡೆ ಮೂವ್ ಆಗಬೇಕು. ಯಾಕಂದ್ರೆ ಸೊಲ್ಯೂಟ್ ಇರುತ್ತೆ, ಸಾಲ್ವೆಂಟ್ ಇರುತ್ತೆ. ಯಾಕೆ ಸಾಲ್ವೆಂಟ್ ಮಾತ್ರ ಮೂವ್ ಆಗುತ್ತೆ? ಸೊ ದಟ್ ಈಸ್ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್ which allows only solvent molecules to pass through it but not solute particles. ಈಗ ಇಲ್ಲಿರ್ತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ, ಸೊಲ್ಯೂಷನ್ ಇರತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ಈ ಕಡೆ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಆದ್ರೆ ಈ ಪ್ರೋಸೆಸ್ ಈ ಕಡೆಯಿಂದ ಈ ಕಡೆ ಬರ್ತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿ ಆಸ್ಮೋಸಿಸ್ ಆಗಲ್ಲ, ರಿವರ್ಸ್ ಆಸ್ಮೋಸಿಸ್ ಆಗಲ್ಲ. ಈಗ ಅಲ್ಲಿಗೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಈ ಕಡೆ ಬರೋದು ಅವಾಯ್ಡ್ ಆಯ್ತು ಅಂದ್ರೆ ಈ ಪ್ರೆಷರ್ ನ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್, the external pressure which is higher than that of the osmotic pressure. It's a very important concept and very easy to remember. So just a solvent molecule solution kada barta hai osmosis through semi permeable membrane. So just I want to prevent the osmosis, andre ee kade bartakanta solvent molecules na prevent madodu, stop ಮಾಡಬೇಕು. Just I am going to apply the pressure, that pressure is called as osmotic pressure. Already we have discussed. So now our intention is to move the solvent molecules from solution side to solvent side. So just I am going to apply the pressure greater than osmotic pressure. Osmotic pressure ಗಿಂತ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ನಾನು ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿರ್ತಕ್ಕಂತ ಸೊಲ್ಯೂಷನ್ ಇರ್ತಕ್ಕಂತ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ, they are comes out from the solution and moving towards the solvent side. Now the process of osmosis is reversed. That process is called as reverse osmosis. So what is the concept behind the reverse osmosis? I think it is clear. So reverse osmosis andre the process of movement of the reversing the direction of osmosis by applying the pressure greater than osmotic pressure. It's a very important condition. By applying the pressure which is greater than osmotic pressure on which side? On the solution side ಅಥವಾ solution of higher concentration side. ಯಾಕೆ ಸರ್ solution of higher concentration side ಅಂತ ಹೋಗಬೇಕು ಅಂದ್ರೆ sometimes ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ನಾಲ್ಕು ಹೇಳಿದೆ ನಿಮಗೆ. ಸೊ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ತಗೊಂಡಾಗ ಈ ಕಡೆ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೊಲ್ಯೂಷನ್ ತಗೋಬಹುದು, ಈ ಕಡೆ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ತಗೋಬಹುದು. ಸೊ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡೆ ಹೋಗ್ತಿದ್ರೆ that is osmosis. Now I am going to apply the pressure on the higher concentration side just to stop osmosis, that is called as osmotic pressure. Now the pressure which is greater than osmotic pressure ಗಿಂತ ಜಾಸ್ತಿ ಅಪ್ಲೈ ಮಾಡಿದೆ ಅಂದ್ರೆ the solvent molecules move from which side higher concentration to lower concentration side. lower to higher ಆಯ್ತು ಅಂದ್ರೆ that is osmosis. ಅದೇ higher concentration side ಇಂದ lower concentration ಕಡೆ ಹೋಗ್ತಾ ಇದೆ ಅಥವಾ solution side ಇಂದ solvent ಕಡೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ solvents molecules ಅಂದಾಗ that process is called as reverse osmosis. Then how to define what is meant by reverse osmosis and mention the condition for reverse osmosis. That is the process of reversing the direction of osmosis. By applying, it's very important, by applying the pressure greater than osmotic pressure, on its side, solution side, ಅಥವಾ on solution of higher concentration side. That is the process of reversing the direction of osmosis. The process of reversing the direction of osmosis by applying the pressure which is greater than osmotic pressure. This is very important. Pressure should be greater than osmotic pressure. On which side we are going to apply the osmotic pressure on the solution side or solution of higher concentration side. Okay. That is called as reverse osmosis. I will define once again what is reverse osmosis. The process of reversing the direction of osmosis by applying the pressure greater than osmotic pressure on solution side. So sometimes ಇನ್ನೊಂದು ತರ ಬೇಕಾದ್ರೆ ಡಿಫೈನ್ ಮಾಡಬಹುದು. The flow of solvent out of the solution. The flow of solvent out of the solution by applying pressure greater than osmotic pressure on solution of higher concentration side or just solution side. So it is a simple definition. The flow of solvent molecules out of the solution. And the solution in the solvent molecules are solution in the solvent solution in the higher concentration in the so therefore the flow of solvent out of the solution the so by applying the pressure greater than osmotic pressure. And very important thing is ನೀವು ಯಾವುದೇ ಸುಮ್ಮನೆ solvent molecules ಆಗದೆ ಹೋಗುದಿಲ್ಲ. Reverse osmosis ಆಗಬೇಕು ಅಂದ್ರೆ whatever the pressure we are going to apply on the solution side that should be greater than osmotic pressure. Sir osmotic pressure ಮಾತ್ರ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, osmosis ಆಗ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಈಗ ನಾವು ಪ್ರೋಸೆಸ್ ಆಫ್ ಆಸ್ಮೋಸಿಸ್ ಏನ್ಬೇಕು ರಿವರ್ಸ್ ಮಾಡಬೇಕು ಅಂದಾಗ ಮತ್ತೆ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಈ ಕಡೆಯಿಂದ ಬರ್ತಕ್ಕಂಥ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅವಾಯ್ಡ್ ಆಗುತ್ತೆ, ಈ ಕಡೆಯಿಂದ ಮೂವ್ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಇಂದ ಸಾಲ್ವೆಂಟ್ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ. ದ ಪ್ರೋಸೆಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ರಿವರ್ಸ್ ಆಸ್ಮೋಸಿಸ್. ಅಂಡ್ ದಿಸ್ ಇಸ್ ಅ very important basic principle that is used in desalination of seawater. Desalination of seawater, very important for 1 mark. Name the basic principle used in desalination of seawater. Desalination of seawater ಅಂದ್ರೆ ಈಗ seawater consists of salt. Saline ಅಂದ್ರೆ salt ಇರುತ್ತೆ. D ಅಂದ್ರೆ remove ಅಂದ್ರೆ salt ಅನ್ನು remove ಮಾಡಬೇಕು, pure water ಮಾತ್ರ ತಗೋಬೇಕು. So that is the process desalination of seawater. What is the basic principle used in desalination of seawater? It's very important for 1 mark. That is basic principle is reverse osmosis. ಅಥವಾ ಇನ್ನು ರಿವರ್ಸ್ ಕೇಸ್ ಅಲ್ಲಿ ನಾವು ಕ್ವೆಶ್ಚನ್ ಕೇಳಬಹುದು. Write the one application of reverse osmosis ಅಂತ ಕೇಳಬಹುದು. Mention one application, write one application of reverse osmosis. 1 mark question. Very simple. Desalination of seawater. It's an important application. That is purification of water or removal of salt from the seawater. It's the best example, best application of reverse osmosis. Usual question: what is meant by reverse osmosis? Mention its one application. So what is meant by reverse osmosis? Name the basic principle that is used in the desalination of seawater. That's also 1 mark question. What is the condition of pressure to carry out the reverse osmosis? That is the pressure should be greater than osmotic pressure. So the more term osmosis, osmotic pressure, reverse osmosis. Just I will explain simply. So solvent molecule solution kade hogta ide, that is osmosis. ಅದನ್ನ ಸ್ಟಾಪ್ ಮಾಡೋದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ, I'm going to apply the pressure on the solution side, that is osmotic pressure. If I apply the pressure greater than osmotic pressure on the solution side, ಇದೇ pressure ಏನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ solution side ಅದಕ್ಕೆ osmotic pressure ಜಾಸ್ತಿ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರೆ solvent molecule solution ಇಂದ solvent ಕಡೆ ಹೋಗುತ್ತೆ, ಅದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ. That is called reverse osmosis. It's a very easy to remember all these three things, that is reverse osmosis, osmosis and osmotic pressure. And now desalination of seawater ಅಂತ ಹೇಳ್ತಾರೆ. So ಅದನ್ನ ಯಾವ ರೀತಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋದು? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸೊ ಹಿಯರ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ತಗೊಂಡ್ಬಿಟ್ಟು ಏನು ತಗೊಂಡ್ತೀನಿ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ a sea water. Remember, sea water is not a pure water, that is a solution actually, because it consists of number of salts. So ಈ ಕಡೆ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ a pure water. Just I am going to take a pure water. So ನಾನು ಏನು ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಆಗಲಿ ಅಥವಾ ಎಕ್ಸ್ಟ್ರಾ ಪ್ರೆಷರ್ ಏನು ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂತ ಏನಾಗುತ್ತೆ, ಪ್ಯೂರ್ ವಾಟರ್ ಅಲ್ಲಿ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್, ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಸಿ ವಾಟರ್ ಕಡೆ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಆಸ್ಮೋಸಿಸ್ ಥ್ರೂ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್. ಸೊ ಈ ಕಡೆಯಿಂದ ಬರ್ತೀನಿ ಪ್ಯೂರ್ ವಾಟರ್ ಇರ್ತಕ್ಕಂಥ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಈ ಕಡೆ ಬರೋದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡೋದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್. ದಟ್ ಪ್ರೆಷರ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ osmotic pressure, and remember that is applied on the solution side. Here the solution side is nothing but sea water. Again, if I apply the pressure and then osmotic pressure on the sea water, what happens? We see what there is consists of number of salts and also water. That water molecule is the solvent molecule, because of semi-permeable membrane allows only solvent molecules. This water molecules present in the sea water is comes out from the sea water. Nothing but sea water the pure water nagutte, ee kade pure water component ge nagutte move agutte by applying the pressure greater than osmotic pressure. That process is again called as reverse osmosis. That is a simple application of reverse osmosis, that is desalination of sea water. And what type of the semi-permeable membrane that is used in reverse osmosis? That is cellulose acetate. cellulose acetate is one of the best example for a semi-permeable membrane that is especially used in reverse osmosis. So that is cellulose acetate, that is semi-permeable membrane used in the process of reverse osmosis. I think it's clear about the osmosis, osmotic pressure and reverse osmosis. And one more concept under the osmotic pressure and osmosis, that are isotonic solutions. Hypotonic solution and hypertonic solution. It's a very important concept for 1 mark in theory examination as well as in theory. So that are isotonic solutions. Isotonic solution, and one more hypotonic solution, and one more is hypertonic solution. Similar plural ತುಂಬಾ applicable ಆಗುತ್ತೆ. Isotonic solutions ಅಂತ ಹೇಳಬೇಕು, hypertonic solution ಅಂತ ಹೇಳಬೇಕು. Hypotonic solution that is singular, hypertonic solution that's also singular. So one more question will give that. What are isotonic solutions? What is meant by hypotonic solution? What is meant by hypertonic solution? So so let me take two solutions. That is solution 1 and one more, that is solution 2. Solution 1 and solution 2 having the concentration that is C1 and here the concentration is C2. Where C is nothing but polarity. C1 is the concentration of solution 1 and C2 is the concentration of solution 2. And these solution having the osmotic pressure that is pi 1 and this solution having the osmotic pressure that is pi 2. So these two solutions are said to be isotonic solutions. Here the solutions na isotonic solutions anta helbeku andre what is the condition? So at a given temperature, in a temperature of the constant at a given temperature, so if the two solutions having the same osmotic pressure, that is pi 1 is equal to pi 2. ಎರಡು solutions ತಗೊಂಡಾಗ ಎರಡು solutions osmotic pressure same ಇದೆ ಅಂತಂದ್ರೆ those type of the solutions are called as isotonic solution. This is very important for 1 mark. What are isotonic solutions ಅಂತ ಕೇಳ್ತಾರೆ. So isotonic solutions plural ಇರಬೇಕು, ಯಾಕಂದ್ರೆ ಕಂಪ್ಯಾರಿಸನ್ ಕೊಡ್ತಾರೆ, ಕಂಪೇರ್ ಮಾಡಬೇಕು, ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಅದು ಈಕ್ವಲ್ ಇದೆ ಅಂದ್ರೆ those solutions are called as isotonic solutions. Isotonic solutions ಅಂದ್ರೆ solutions, the two solutions having same osmotic pressure at a given temperature. Solutions having same osmotic pressure at a given temperature is called as isotonic solution. But in the given example, pi 1 is equal to pi 2. So we know that pi is equal to CRT. Pi is proportional to C. RT, R is the gas constant, T is the temperature. So here now solution 1 apply madaga pi 1 is equal to C1 RT. So concentration is different. Given temperature at the temperature constant is R value is also constant, and again so pi 2 that is equal to C2 RT into pi 1 is equal to C1 RT, pi 2 is equal to C2 RT. RT gets cancelled. Again, C1 is equal to C2. That's a very important concept again. Isotonic solutions having same concentrations, and at the same time isotonic solutions having same osmotic pressure. So what is the result? The conclusion ಏನು ಕೊಡಬಹುದು ಅಂದ್ರೆ ಎರಡು solution ಗೆ concentration same ಇದೆ ಅಂತಂದ್ರೆ 100% ಆ solutions ಗೆ ಏನಾಗಿರುತ್ತೆ osmotic pressure same ಇರುತ್ತೆ. This is a very important concept. So ನಿಮ್ಮ competitive exams ಅಲ್ಲಿ ಎರಡು solution ಕೊಡ್ತಾರೆ pair. Solution A, solution B ಅಂತ 4 pair ಕೊಡ್ತಾರೆ. So 4 pair ಅಲ್ಲಿ among these pairs which pair are the isotonic solutions ಅಂತ ಕೇಳ್ತಾರೆ. ಆಗ ನಿಮಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು, ಎಲ್ಲದಕ್ಕೂ ನೀವು ಪೈ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. W2 RT 2000 V in ML ಅವೆಲ್ಲ ತಗೊಂಡು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ ಟೇಕ್ಸ್ ಟೈಮ್. ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಕ್ವಶ್ಚನ್ 1 ಮಿನಿಟ್ ಸಾಲ್ವ್ ಆಗಬೇಕು. ಆ ಟೈಮ್ ಅಲ್ಲಿ ದಿಸ್ ಇಸ್ ವೆರಿ ಯೂಸ್ಫುಲ್. ಅಂದ್ರೆ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಸೊಲ್ಯೂಷನ್ ಗೆ ಜಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಕ್ವಲ್ ಬರ್ತಾ ಇದೆ ಸೊಲ್ಯೂಷನ್ ಗೆ ಅಂದ್ರೆ 100% ಅದಕ್ಕೆ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಆಗಿರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ ಕನ್ಕ್ಲೂಷನ್ ಏನು ಕೊಡಬಹುದು ಅಂದ್ರೆ ಸೊ ದ ಸೊಲ್ಯೂಷನ್ಸ್ isotonic solutions having same concentrations. Having same concentrations. Concentration ಏನಾಗಿರುತ್ತೆ same ಇರುತ್ತೆ. So ಮತ್ತೆ solutions having same osmotic pressure. The concentration same ಇದೆ ಅಂದ್ರೆ 100% ಅದು ಏನಾಗಿರುತ್ತೆ osmotic pressure ಸಹ ಏನಾಗಿರುತ್ತೆ same ಇರುತ್ತೆ. It's a proof. Pi 1 is equal to pi 2 ಆಗಿದೆ ಅಂದ್ರೆ according to our equation pi is equal to CRT. So pi 1 is equal to C1 into RT. Pi 2 is equal to C2 into RT. RT gets cancelled. C1 is equal to C2. Therefore, isotonic solutions ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ so definitely they are having the same concentration at the same time they are having the same osmotic pressure. But one marker ಕೇಳಿದಾಗ ನೀವು ಆದಷ್ಟು ಇದನ್ನೇ ಬರೀಬೇಕು. Solutions having same osmotic pressure at a given temperature is called as isotonic solutions ಅಂತ ಹೇಳ್ತೀವಿ. So that's about the isotonic solutions. So one more hypotonic solution ಅಂತ ಹೇಳ್ತಾರೆ. Let me take solution 1 and solution 2. Just I am going to take assumption to one time. Pi 1 is greater than pi 2. But osmotic pressure of the solution 1 is higher compared to osmotic pressure of the solution 2. ಯಾವುದಕ್ಕೆ ನಿಮಗೆ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ solution 1 ಗೆ osmotic pressure ಜಾಸ್ತಿ ಇದೆ. ಯಾವ solution ಗೆ osmotic pressure ಜಾಸ್ತಿ ಇರುತ್ತೋ compared to other with respect to other, those types of solution is called as that type of solution is called as hypertonic solution. That is the solution having higher osmotic pressure with respect to other. ಬೇರೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಇದಕ್ಕೆ osmotic pressure ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಆ ಟೈಪ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನ we can call as hypertonic solution ಅಂತ ಕರೀತೀವಿ. ಸೊ ಹಾಗಾದ್ರೆ pi 1 is greater than pi 2 ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. ಸೊಲ್ಯೂಷನ್ 1 ಗೆ ಏನಾಗಿದೆ osmotic pressure ಜಾಸ್ತಿ ಇದೆ ಕಂಪೇರ್ ಟು ಸೊಲ್ಯೂಷನ್ 2. ಹಾಗಾದ್ರೆ 1 and 2 ನಲ್ಲಿ ಯಾವುದು hypertonic solution ಅಂದ್ರೆ solution 1 is the hypertonic solution because pi 1, that is osmotic pressure of the solution 1 is higher than that of the osmotic pressure of solution 2 ಅಂತ ಹೇಳಿದೀನಿ. ಯಾವುದಕ್ಕೆ osmotic pressure ಜಾಸ್ತಿ ಇರುತ್ತೆ with respect to other compared to other, that type of the solution is called as hypertonic solution. So that we can easily say what is hypotonic solution. And if you are the hypotonic solution ಯಾವುದು ಅಂದ್ರೆ we can easily say 2 is the hypotonic solution. So that is the solution which is having solution having lower osmotic pressure with respect to other. Better compare ಮಾಡಿದ್ರೆ solution ಗೆ lower osmotic pressure ಇತ್ತು ಅಂತ that is hypotonic solution. So hypotonic solution ಅಂದ್ರೆ solution having higher osmotic pressure with respect to other. ಬೇರೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ higher osmotic pressure ಇತ್ತು ಅಂದ್ರೆ ಅದು hypertonic solution ಆಗುತ್ತೆ. So ಬೇರೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಒಂದು ಕಂಪೇರ್ lower osmotic pressure ಇರುತ್ತೆ, that is called as hypotonic solution. That can be explained by taking simple example. So let me take 3 beakers. So 3 beakers. So here in the beaker I am going to take 0.9% W by V NaCl solution. So here also I am going to take 0.9% W by V NaCl solution. Here also we can take 0.9% W by V mass by volume percentage, that is NaCl solution. So ಇದರಲ್ಲಿ 0.9% W by NaCl solution ಇದೆ. ಇನ್ನೊಂದು beaker ಅಲ್ಲಿ just I am going to take greater than 0.9% W by V NaCl solution and one more beaker ಅಲ್ಲಿ that is less than 0.9% W by V NaCl solution. So here there is a one more question that was very important for CET. So what happens the size of blood cells? ಈ ಮೂರು beaker ಏನು ಮಾಡ್ತೀನಿ blood cells ನ add ಮಾಡ್ತೀನಿ. So blood cells ನ add ಮಾಡಿದಾಗ what happens the size of blood cells when the blood cells are added in. So if you take the blood cells, that is taken as a blood cells. So it also is the blood cell. So it also blood cells. So it one blood cell ಅಂತ ತಗೊಳ್ಳಿ, ಇದು ಒಂದು blood cell, ಇದು ಒಂದು blood cell. So blood cells ಅನ್ನ 0.9% W by NaCl solution ಹಾಕಿದಾಗ ಇದರ ಸೈಜ್ ಏನಾಗುತ್ತೆ? ಅದೇ greater than 0.9% W by NaCl solution ಹಾಕಿದಾಗ ಇದೇನಾಗುತ್ತೆ? Again size of blood cells to add it by when it is added to a solution that is less than 0.9% W by V in NaCl solution. So before that, so that is 0.9% W by V NaCl solution is called as normal saline solution. Normal saline solution. This is isotonic with. This is isotonic with fluid inside the blood cells. Fluid inside the blood cells. So this is very important. 0.9% NaCl by V, that is a mass percentage NaCl solution. It's called as normal saline solution. So this solution is isotonic with the fluid inside the blood cells. So blood cells ಒಳಗಡೆ ಏನು fluid ಇದೆ ಈ ತರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮತ್ತೆ 0.9% W NaCl solution ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂದ್ರೆ ಎರಡು ಸೈನ್ ಆಗಿರುತ್ತೆ ಸೇಮ್ ಇರಬೇಕು ಬಿಕಾಸ್ that is called as isotonic. ಐಸೋಟೋನಿಕ್ ಅಂದಾಗ ಇದರೊಳಗಡೆ ಇರತಕ್ಕಂತ ಫ್ಲೂಯಿಡ್ ಏನಿದೆ ಸೊ ಜೊತೆಗೆ 0.9% WBV NaCl solution ಇವೆರಡಕ್ಕೂ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗಿರುತ್ತೆ ದಟ್ ಈಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ 0.9% WBV NaCl solution that is equal to concentration of the fluid inside the blood cells. ಎರಡರದ್ದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೇಮ್ ಇದೆ ಅಂದಾಗ there is no osmosis. ಯಾಕಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ವೇರಿ ಇತ್ತು ಅಂದ್ರೆ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ನೊಂದು ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇತ್ತು ಅಂದ್ರೆ ಮಾತ್ರ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಆಸ್ಮೋಸಿಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಇರ್ತಕ್ಕಂಥ ಫ್ಲೂಯಿಡ್ ಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮತ್ತೆ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಕಾನ್ಸಂಟ್ರೇಷನ್ ದಟ್ ಇಸ್ 0.9% W/V ಇವೆರಡರದ್ದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ. ದಟ್ಸ್ ವೈ ದಟ್ ಈಸ್ ಟೇಕನ್ ಆಸ್ ಐಸೋಟೋನಿಕ್ ಅಂತ ಹೇಳ್ತೀವಿ. That is normal saline solution is isotonic with the fluid inside the blood cells andre so these two are isotonic with each other. There is no change in size of the blood cells. No change in size of blood cells. ಯಾಕೆ ನಿಮಗೆ ಸೈಜ್ ಚೇಂಜ್ ಆಗಲ್ಲ ಅಂದ್ರೆ ಇನ್ ಕೇಸ್ ಇದು ಆಸ್ಮೋಸಿಸ್ ಆಗಿದ್ರೆ ಇಲ್ಲ ಫ್ಲೂಯಿಡ್ ಏನಾಗಬೇಕು ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ವಾಟರ್ ಕಂಟೆಂಟ್ ಆಚೆ ಬರಬೇಕು. ವಾಟರ್ ಕಂಟೆಂಟ್ ಡ್ರೆಸ್ ಇಂದ ಆಚೆ ಬಂತು ಅಂದ್ರೆ ಸ್ಟ್ರಿಂಕ್ ಆಗುತ್ತೆ, ಸೈಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇಲ್ಲ ನಿಮ್ಗೆ ಏನಾದ್ರು ಇಲ್ಲಿ ನಿಮಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಇದೆ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಇದೆ ಅಂತಂದ್ರೆ ವಾಟರ್ ಇನ್ಸೈಡ್ ಹೋಗುತ್ತೆ ಅವಾಗ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಏನಾಗುತ್ತೆ ಸ್ವೆಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಸೈಜ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಏನಾಗಬೇಕು ಸ್ವೆಲ್ ಆಗಬೇಕು ಇಲ್ಲ ಸ್ಟ್ರಿಂಕ್ ಆಗಬೇಕು. ಯಾವಾಗ ಇವೆರಡು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫ್ಲೂಯಿಡ್ ಇನ್ಸೈಡ್ ದ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೇಮ್ ಇದ್ರೆ ಸೊ ಸೇಮ್ ಇದ್ರೆ ಇದ್ದಾಗ ಸೇಮ್ ಇದೆ ಅಂತ ಅಂದಾಗ ಏನಾಗುತ್ತೆ 100% of the solvent to move out because therefore size of the blood cells remains same, there is no change. But in this case so what happens to the size of blood cells when it is placed in the saline solution that is NaCl solution having the concentration greater than 0.9% ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ಅಂದ್ರೆ ಅರ್ಥ ಏನಾಯ್ತು ಇವೆರಡರದ್ದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೇಮ್ ಇತ್ತು ಅದರಿಂದ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇತ್ತು there is no osmosis therefore no change in the size of blood cells. ಇಲ್ಲಿ ಏನಾಗಿದೆ ನಾರ್ಮಲ್ saline solution ಕಾನ್ಸಂಟ್ರೇಷನ್ 0.9% ಗಿಂತ ಜಾಸ್ತಿ ಆಯಿತು. ಅಲ್ಲಿ ಅರ್ಥ ಇಲ್ಲಿ NaCl solution ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಯಿತು ಕಂಪೇರ್ ಟು ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಅಂದ್ರೆ ಫ್ಲೂಯಿಡ್ ಇನ್ಸೈಡ್ ದ ಬ್ಲಡ್ ಸೆಲ್ಸ್. ಯಾವಾಗ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಯಿತು ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಅಂದ್ರೆ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಇರ್ತಕ್ಕಂಥ ವಾಟರ್ ಕಂಟೆಂಟ್ ಏನಾಗುತ್ತೆ ದಟ್ ಈಸ್ ಕಮ್ಸ್ ಔಟ್. So when the water flow out of the blood cells ಆಚೆ ಬಂತು ಅಂದ್ರೆ what happens to the size of blood cells? The size of blood cells decreases. Size of blood cells decreases. Or simply we can say that is shrinks. ಅಂದ್ರೆ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಏನಾಗುತ್ತೆ ಸ್ಟ್ರಿಂಕ್ ಆಗುತ್ತೆ ಸೈಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ವಾಟರ್ ವಿಲ್ ಫ್ಲೋ ಔಟ್ ಆಫ್ ದಿ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಬಿಕಾಸ್ NaCl ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಗಿದೆ 0.9% ಗಿಂತ ಜಾಸ್ತಿ ಆಗಿ ತಗೊಂಡಾಗ ಕಂಪೇರ್ ಟು ಫ್ಲೂಯಿಡ್ ಇನ್ಸೈಡ್ ದ ಬ್ಲಡ್ ಸೆಲ್ಸ್ this concentration is very high so therefore the water will flow out of this water will flow from lower concentration to higher so therefore ಯಾವಾಗ ವಾಟರ್ ನಿಮಗೆ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಆಚೆ ಬರುತ್ತೋ actually the size of the blood cells decreases ಅಥವಾ blood cells are strained. So and here so when the solution the blood cells are placed in the NaCl solution having the concentration less than 0.9% ಎರಡರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಕ್ವಲ್ ಆಗಿರುವಾಗ 0.9% ಇದ್ರೆ ಬಟ್ ಈಗ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಯಿತು ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗಿಂತ ಅದರೊಳಗಿಂತ ಫ್ಲೂಯಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗಿಂತ 0.9% ಕಡಿಮೆ ಇದೆ. ಸೊ ಯಾವಾಗ ಇದು ಕಡಿಮೆ ಆಗುತ್ತೋ ಅರ್ಥ ಏನಾಯ್ತು ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಫ್ಲೂಯಿಡ್ ಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಆಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಇದು ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಗುತ್ತೆ ಫ್ಲೂಯಿಡ್ ಇನ್ಸೈಡ್ ದ ಬ್ಲಡ್ ಸೆಲ್ಸ್ ಇಲ್ಲಿ ಲೋಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಯಿತು ಆಗ ವಾಟರ್ ಆಗುತ್ತೆ ದಟ್ ಈಸ್ ಫ್ಲೋ ಇಂಟು ದ ಬ್ಲಡ್ ಸೆಲ್ಸ್. So the semi-permeable area so blood cells again walls into the access semi-permeable membrane so water move inside the blood cells and what happens the size of blood cells increases.